Yes, today we'll discuss here redundancy protocol. In that redundancy, we have a family first hope redundancy protocols FHRP. FHRP stands for first hope redundancy protocol. And before that, we'll discuss something requirement of redundancy. What is the reason behind the FHRP? If FHRP is not there, which kind of issues we'll face? So we'll discuss here something, then we'll move. Here we have a one customer edge router, branch router, and this branch router connected to some access switches, and access switches is connected to some multiple users. Assume like multiple users are connected here. These all are LAN users. When LAN users connected to access switches, likewise. And this access which is connected to some ISP, it's ISP internet service provider. And ISP2, we have a connectivity that servers are internet. If internet means anything, so it's kind of Google. Can assume google.com. If we'll reach Google, then we can reach anywhere google.com, or it's kind of internet, any IP address. So the reachability like this, it will be happen. Now, and everything is for working fine with our customer edge router. We can reach sorry, customer edge router, and customer edge router is connected to some multi-layer switch or access switch. Then this is all our LAN network. This is our entire LAN network, local area network. This is our LAN. This is our topology. So now tell me, if I want to reach the internet, so here we have a one IP address. This is our prefix 10.1. This is a gateway, and I'll give the IP addresses to for individual user for any IP addresses 192.168.10.10 for this PC, and for these PCs 20 dot so 10.20 192.168.20 10.20 are I said 30 PC, and this one is a 40. So the gateway is our default gateway is here, which IP will use mostly 192.168.10.1 IP address, whichever the route connected to our gateway. So its gateway, its exit or entry point of different network. If you want to reach some different network from this network to another network, anyway, we'll use in internet type. That time we'll use here NAT. Now we are not discussing about NAT, network address translation. Now we are not discussing. We'll discuss later on sessions, but anyway we need required from this is our private IP addresses, and these all are here we'll use mostly public IP addresses 11.1.1, some public IP addresses. If I want to reach from private to public, so we need a NAT, network address translation. Anyway, we are not discussing NAT, just have given the overview. So we'll use any IP address here. So if I want to move from LAN to WAN, so here the entire process is like we need a gateway to reach one location, one subnet to another subnet. So working everything is fine. if this link is goes down, then we can able to reach internet. It is possible. The possibility is there. We can able to reach
No,
if this link is down. So any solution for that?
we need to use default gateway, like
Already we are
another
using the default.
red. I mean duplicate.
Okay, duplicate PC. Okay, I'll use one more access switch here, and access switch 2, I'll use here same connectivity and same connectivity. Then this PC is connected to, like, again this access switch. This is a switch, and this switch is connected to again this PC. Okay, now here if I'll change the gateway also, any benefit? If any benefit, this link is down. In LAN side, if I'll do something, any changes, or I'll keep it here one more switch. If I'll add on one more switch also, I'll give
No
likewise
use.
also, then no use. So any options for that? Any better
We need to
option?
use duplicate default gateway for that too.
Okay, fine.
Another.
We'll use here. Okay, fine. If you want to say here, I'll use the different default gate 192, 168. No, I'll use 10 dot. So same network we must have to use. So same network only, because this are entire we have to use. So if you are using different network also,
Mm.
here we are using the router, then we can use different network also. 20.10. So, okay, 20.1 I'll use. So this is the default gateway. And if I'll give the IP address, like I have to change the IP address series again for this router, for this user. So now this time I have to give the second 192.168, 20.10 for this PC again. And default gateway is here. I'll use 192.168, 20.1. I'll give the default gateway for this. Okay.
Yeah,
Now tell
but
me, we can able to reach.
we should definitely use the other network, not the same network, right?
Yeah, I have. Yeah, definitely we have to use. That is the reason I have taken, because L3 device we are using here. So we have to take a different network. So that is the reason I have taken the different network. So you said different gateway, different default gateway. That is the reason I have taken. If I'll change this to here, first of all, no use also. So which link is down? The uplink is down. This is our uplink. Sorry, uplink is down now. This uplink is down, then what is the use also here? If I'll change the default gateway also, if I'll change, this is not a recommended also in real time. Will not give the two different subnets at one PC. It's not, this is a PC. Will not give likewise in real time, actually. Will not give at one PC only two different network. This is a different network and this one is a different network. Mostly will not give this kind of networks. And if you are giving also, so think about it. Any usage is there. Uplink is down here. Have you got it?
So we
Everyone.
cannot use another router for that.
Definitely. For that, we'll use different network. Okay, good. Here I am using different net router. Okay. This is a different router. This is a customer edge. Again, customer edge router. Better will draw. Okay, we will discuss here only. This is the customer edge router.
Now we can connect this
And
with this new router and we can make the connection with.
this, yeah, okay, fine. We'll connect likewise. Okay, good. We'll connect likewise. We'll give the default gateway now this time here. Okay. Now this link is not required. We'll give the default gateway for this PCA or any different PCs. Okay, now tell me if this ISP is down. That ISP only down. We have a two routers, multi-home network, multi-home network. We have a two routers, but now this time not uplink. The entire ISP is down. This ISP one is down. So now we can able to reach internet.
Yesterday, as we discussed, like BGP, we can use multiple ISPs, right, Ali?
Okay, good. Fine. Fine. Understood. Now what we'll do? We have a two customer edge routers and two customer edge routers and two ISPs. And these two ISPs are connected like this. And ISP1 and ISP2. And this is a customer edge 1. And this is a second customer edge router. And these customer edge routers are connected to some multi-layer switch. And this multi-layer switch is connected to some host. Now here we are taking only one subnet only because this is entire our LAN network. So this is our entire our LAN network. This is our LAN network. So what we'll do, we'll take a 192 192.168.10.1 and /24. This is a network we'll use, and for this interface we'll use 192.168.10.2 for this interface. And we have a two ISPs here. And these two ISPs are this user having the IP addresses 192.168.10.10 and default gateway, which I have to give. Now tell me, which I have to give the default gateway in this case.
So, which one is active? That one we have to provide for the default gateway.
So you tell me now which one is active. Think about it. This is a customer edge 1 and this is a customer edge 2. It's a first router and this is a second router. We'll take it as a this is a first router. We'll give preference of first. So we'll give the IP address of default gateways. This one. But default gateways 192.168 and 10.1. Now we can reachable to internet easily. Yes. Through this interface, we can reach internet easily. Yes. Possibility is there. Okay. Now this router is down. In this case, routers, this router is down now. Not ISPs. ISPs are working fine. Both ISPs are working fine. So we have a issue. So till we cannot able to reach. Now we can able to reach because the whichever the default gateway is there, through that default gateway only we can connect to different networks. If we want to reach different network, so we need a default gateway. So I have given the default gateways this interface. Now this interface is down, or this router is down, or this interface is down. Something problem with here in this LAN segment. So I have to change default gateway, right? So now this time I'll give the 2. Okay, now we can able to reach from here to here. Yes. Understood?
Yes, Salim.
Now this router is came up again. This is working fine. Now I want to change because here we are using the 10 Mbps link. This is 10 Mbps link, 10 MB link, and this one is the less 2 MB link. So which one is the best? 2 or 10? So based on that, 10 MB is best. So again, I have to move and I'll change the default gateway. So I'm not in shift time. So no one is there. Network engineer is not there. So this PC is this user is getting the issue. So no one is changing the default gateway. So he can able to reach the internet or not. He cannot. Now you think no one in shift. He got a he is facing the issue. Otherwise it is a server. This one is a server. Entire thing happen in the server only. This is a server machine. In the server machine only, entire users are not communicating this server. In this server only entire files will happen. So that time also issue.
So that's why we need to
Any
use the
solution?
gateway protocols.
Yes, now you got it. That is the reason we need a redundancy protocol. First hope redundancy protocol. What we'll do here, we'll give the one virtual IP address here. We are not using physical. Here we are using virtual gateway. Gateway we are using which gateway? Virtual gateway we are using. Anything if you want, anything you can use in this same network. 10 dot. Now we are using 5. The same subnet we have to use. So if I'll give the subnet 5 here, so if I will give the 5 here, default gateway is 5, virtual gateway. So if this link also goes down, no issue, he can able to reach from through this interface. If this link is down, now this link is working perfect. So he can able to reach from this network through internet. So in this case, we have to give virtual gateway. It is not a physical interface. This is a virtual gateway, virtual interface. Virtual
So
interfaces are always up only. Yes.
what if two links goes down?
So two links is goes down. Then we, if you have a budget, then one more router. Take one
Okay.
more router. Connected
Okay.
to likewise. This one is an active router, and this one is a standby router. This one is a listening router. If active router is goes down, then standby will become the active, and listening will move to the standby.
Okay.
It will be moved to the standby. If it is this router again came up, then here we are using the 10 Mbps compared to 2 Mbps. 10 Mbps is best. So again it will be moved to the active. Then it will be moved to the standby. Then again it will be moved to the listening state. It will be wait. Any queries? Till anyone understood what is the reason behind redundancy protocol? Mahesh, Nikila, Rikvita.
Yeah, no doubt, Salim.
Yes, Salim, understood.
So yes, screen is visible.
Yes.
Yes.
Yeah. Here we have a FHRP. It's it's a redundancy protocol. And if any single point of failure, then we have a redundancy and duplicate devices like links we have to, those will be elected to active devices, then it will be, we can easily communicate internet whichever. So there we have a three ways. So first one is three types of FHRP protocols we have. First one is HSRP and second one is VRRP and third one is GLBP. So HSRP stands by HSRP stand by hard standby redundancy router protocol. Hard standby router protocol or redundancy protocol. No issue. And virtual router redundancy protocol VRRP stands by, and GLBP stands by gateway load balancing protocol, and HSRP and GLBP both are Cisco proprietary. If both end Cisco devices, then only it will be work. If both the end Cisco devices, here we are using one Cisco device and neighbor also Cisco device, and then only it will be work HSRP and GLBP. If you are using here Cisco and one side is HP device, then neighborship is not found, no neighborship. So ensure both the devices we have to use same, and VRRP is a open standard, IEEE standard. And load balancing, here we don't have any load balancing, and here also, and gateway load balancing only in this protocol only we can achieve the load balancing. What does that mean, load balancing? So here we have a one router and second router and third router, and we have a LAN users. These all are LAN users, and these users are connected to internet ISP, and ISP is connected to one ISP, you can assume. So we have multiple prefixes or multiple LAN users, and this is a one LAN user, second, third, fourth, or likewise. In HSRP case, if we are using this one path means one active router means all the time active router only responsible to send the traffic. Standby it won't possible. In standby means once active is down, then standby take a picture. He will transfer the traffic. Here we cannot achieve the load balancing. Even though we have some commands, if we have multiple VLANs, so for VLAN 10 part, one router is active, and VLAN 20 part, one router is active, and VLAN 10 part, this is an active router, and VLAN 20 part, this is an active router. If you want, you can achieve the load balancing in these cases also. But by default, load balancing is not performed. If someone asked you in interview, we cannot achieve the load balancing in HSRP, VRRP. Yes, we can achieve. Based on the VLAN, we can achieve. For VLAN 10, if this is the active router means he cannot active for VLAN 10. If VLAN 20 part is an active router means he is only the responsible to send the traffic. Here we cannot load balancing properly, but load balancing part only some prefixes part we can achieve the load balance and not 100%. So, but in GLBP part, yes, we can achieve some traffic from this interface. This is active router, and this one also active router, and this one also active router. Entire routers are the routers are the active routers only. Through that, we can achieve the load balancing. That is what. For this is the second path, and he can use this path. PC1 using this path like this. PC1 using sometimes this path, and some packets are moving this path, some packets are moving this path. Based on the availability, it will achieve our goal. in GLBP. But in real time, this protocol will not use. Once you will expert in that, then you will understand what is the reason. But in mostly we are using VRRP. In most organizations will use VRRP protocol. Don't worry. But even though we have to know entire process of entire every routing process. So now we'll move to the further. So here we are using the multicast IP address for version 1 part 224.0.0.2 version 1 part. Here we have a in HSRP two versions we have. HSRP having two versions, version 1 and version 2. So version 1 using the multicast IP address, that is 224.0.0.2 and 224.0.0.102 for version 2. And this is a VRRP multicast IP address and this is a GLBP address. And GLBP and version 2 both are the same, don't confuse it. And now move to the port numbers. So port number 190, 1985 and 112 and 3222. So these are all are the UDP based protocols. Entire FHRP family uses UDP based protocol. So no reliability. If some packets are dropped, then drop only. So here we don't have reliability. So UDP port numbers they are using. So port number basis only will identify the services. Which service? So once we will identify service, we can create the ACLs also. If I want to permit some traffic for this FHRP, yes, I can permit. And if I want to deny some traffic, yes, I can deny also. So those for denying or permitting part, we are using the port number. It is identify the service based on the port number. Will identify the service and timers. Now move to the timers. The hello timer is 3 seconds and dead timer is 10 seconds. So whenever the neighborship in between, so every 3 seconds, my neighbor is alive or not. R1 here we are active. This is the active router, and this one is a standby router. So R2 alive or not. Every 3 seconds they will communicate. If this router is down and this 3 seconds, it will be wait for 10 seconds. It will be wait for 10 seconds. This router, if he is not responding, he is down. So this active will become a standby will become as a active. Standby will become as a active. So those are the timers and same timers here also. And here 1 second and 3 seconds. Based on the skew formula, it will be elected dead timer. This is the formula 256 minus priority divided by 256. Based on that priority, it will be elected timers, dead timers. Now move to the election process, how they will elect. So here we have a R1 customer edge router and this one is the R2 and this is the our LAN network they are communicating. So how they will elect, this is the ISP, how they will elect, this one is a active router and this one is a standby router. How they will elect? Which criteria basis they will elect? Which criteria basis they will elect? First, they will check priority. So by default, priority is every router having 100. Every router having by default priority is 100. So we'll check some. I'll take here one router. One router and for this router, we'll check some configuration. I'll show you the priority. So this is the priority. So the range is priority is 0 to 255. This is the range by default priority range. And if you want to change the priority, yes, we can change whichever you want. But by default priority, how will check? So you can check here by default priority is 100. The default priority is 100. This is how to check. So by default, every router, every interface having the priority is 100. If priority is type, if both the end priority is type, then this router and R1, R2, and they are connected. This one is the 100 priority, and this one also 100 priority. So in priority basis, we cannot elect this one is an active router and this one is a standby router. We cannot election. Election will won't done. So now tell me, it will be moved to the highest IP address. Which IP address? Physical interfaces, whichever we are creating the interfaces, that IP address. This is the 10.1 and this one is a 10.2 and 10.2, whichever having the highest IP address, based on the highest IP address, it will be elect. Highest IP address. Same thing. Here also highest priority and highest IP address. And tiebreaker is highest IP address. Same thing here also. The entire in HSRP, VRRP, GLBP, election process is same. And router roles, here we have router roles, active router and standby routers. So whichever the active router, that router only responsible to communicate different networks. That router only responsible. Here we have two roles, active and standby. But in VRRP, we have an active and a backup router. But in here we have a third router. If many router, those are the listening state. Those are the listening state. But here backup only. One is active, one is backup. If third router is there, that one also backup. Here we have a one AVG, active virtual gateway. And those are the up to 4 AVG available. And that is a group of AVGs. Apart from that, active virtual forwarded routers means 1, 2, 3, 4 routers are these are the AVG routers. If fifth router is there, this one is AVF. This one is AVF. We can achieve up to load balancing 4 routers. It means we can achieve load balancing up to 4. If fifth one is there, if this one is goes down, AVF will become as a AVG. It will AVF become as a AVG. We can achieve load balancing up to 4. If you want to increase, yes, you can increase. No issue. You can increase up to 21024 also. but this many routers will not use, even though we need a concept. So preemption, will discuss preempt in practical, in lab we'll discuss. And we have a virtual, here we have a group also, MAC address. Group of virtual MAC addresses here. This is a XX. This is a constant value 000 and .0 CR. This is a 07, and here we have a 5E, and this is the group number. It will be changed. Actually, here this is the value, this much it will be changed. But here you can check only this much value, only 2 digit only it will be changed. I'll show you in lab how it will be. So based on group number, based on the group number, here we have to take group number. So group number is, if you are taking 1, then this X will become 1. If you are taking group number is 2, this X will become 2. And if you are 3, it will be changed 3. The value will be like, the value will be become like 0.0.000.0 C7 CR07 AC, and instead of this XX means here it will be more value. It means if you are taking group number is, assume like 10, it is a hexadecimal number, in 10 will become is A. So 0A. If you are taking the group number is 11, so 11 means B, values will become B. Likewise, it will be changed. So hexadecimal, it will be changed the value last 2 digits. That is the virtual MAC address. And IPv6, it will be support, and this one is support. Here it won't support. VRRP, it will be not support the IPv6 concept. This is all about FHRP. So this is if 2 routers are Cisco, then only we can use. This is the content only. Go through that. Any doubts? Shall we move to the lab? If you have any queries, ask me. Otherwise, we'll move to the lab. Preemption we'll discuss. I'll show you in lab. Guys, do you have any questions?
No.
Okay.
No, I mean,